Okay, so today we're going to look at lesson 14. This is going to take us from ratio tables and equations to plots on the coordinate plane. I'm sure all of you have seen a coordinate plane before in previous grades, so we'll look at it a little bit closer today. So if we read the problem at the top, it says Kelly is traveling by train with her soccer team from Yonkers, New York to Morgantown, West Virginia for a tournament. The distance between Yonkers and Morgantown is 400 miles. So here's a little bit of information here. We've got 400 miles, and if you notice in this first table here, to go from Yonkers to Morgantown, there's that 400 miles. The trip there will take 8 hours. The train schedule is provided below. So the one thing that I would actually do to this table is add an hours column. We know that it's going to take 8 hours to get to Morgantown, so 8 hours is 400 miles. So what we can do is determine how many hours the rest of the stops are along the way. So in order to figure that out, two things I can do. To get the 8 hours to 400 miles, I can divide that and then see kind of how long it's taking. Another thing I can do is, since it's 8 for the whole thing, I can take 8 and divide it by the 1, 2, 3, 4 spaces that there are, and 8 divided by 4 is 2. So if you think about it, I'm going 2, 4, 6 hours, since the miles are consistent at 100, 200, 300, 400. Another way I could have done that is by taking the 400 miles and dividing it by the 8 hours to see that I'm doing by multiplying by 50. So 8 times 50 gave me that 400, meaning I'm going to do 6 times 50 to get 300, or since I didn't have the 6, I would really be doing 300 divided by 50 because I'm going backwards to get that 6. 200 divided by 50 would get me the 4. 100 divided by 50 would get me that 2 hours. So now it says to create a table to show the time it will take Kelly and her team to travel from Yonkers to each town listed in the schedule, assuming that the ratio of the amount of time traveled to the distance traveled is the same for each city. Then extend the table to include the cumulative time it will take to reach each destination on the ride home. So basically what they're doing is they're just asking us to kind of repeat what we've already done up here. So 2 hours is how long it took to go 100 miles. 4 hours was the 200 miles. And as you can notice, as you're going down the hours column, you're counting by 2s. 2, 4, 6, 8. 2, 4, 6, 8. And they want us to extend it for the way back. So we would just do 10, 12, 14, 16. So counting consistently by 2s down the hours column. If you notice down the miles column, it's just counting by 100. So 100, 200, 300, 400. So then it would continue counting in that same way. 500, 600, 700, 800. Another thing we did realize too, by doing that, 400 is 8 hours, so 400 divided by 8 gave us that 50. To go from hours to miles, we were multiplying by 50. Which means if we're going from miles to hours, or backwards, we're going to use the opposite operation, or inverse operation, which is dividing by 50. So again, if I'm given the number of miles, I would divide by 50 to get the number of hours. If I was given the number of hours, I would multiply by 50 to get the number of miles. The ratio of this table then, remember for a ratio of a table, you're going to put it in simplest form. So if I have 2 to 100, I'll just add it quick over here, I can divide both of these by 2, which would get me 1 to 50. And that's where we get that times 50. So 1 hour is 50 miles. So the ratio is 1 to 50. Now something important to point out here, if it asked me for the value of the table, remember a value is a fraction in simplest form. So the value would be 1/50. Okay, and we always put our first column as our numerator, our second column as our denominator when asked for the ratio or the value of the table, excuse me. If it just asks for a ratio, then we can write it in any form, the colon, the fraction, the word to, whatever it's asking us to write it as. So now the next piece, which we're going to do, is we're going to see how we can put this in a graph. In order to put it on a graph, we use ordered pairs. And ordered pairs have an x coordinate and a y coordinate that go along with the axes on a graph. On a graph, the horizontal is your x and the vertical is your y. So if we look back over to our table, you'll notice next to hours is the letter x. So that means along the x-axis is where we'll be putting our hours. Along the y-axis, we'll be putting miles. We need ordered pairs in order for these to go on a graph. So an ordered pair is where you put a parenthesis, your x coordinate, a comma, and then your y coordinate. So the ordered pair for traveling 2 hours for 100 miles would be 2, 100. For 4 hours, parenthesis, 4, comma, 200, end parenthesis. 6 hours, parenthesis, 6, comma, 300, end parenthesis. The parentheses and the comma are very important, so make sure anytime you're asked to do an ordered pair, you're doing that parenthesis and comma. So I'll just continue doing the same thing, parentheses, the hours, comma, the miles, and end my parentheses, all the way down the rest of the table. So I'm just taking the numbers from the table itself and writing them in parentheses with a comma separating them. So now, if I wanted to put these on the graph, what I would have to do is count how many things I'm trying to put on the graph. So, in the hours column, or across the hours axis, I'm trying to put 1, 2, 3, 4, 5, 6, 7, 8 numbers. If I count, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 lines. What I'm going to do is I'm going to take the 21 and divide it by 8. 8 goes into 21 2 times, and it will have some left over. That just means there's going to be some extra space at the end. So what this is saying is when you divide the number of lines by the number of numbers you want to put on that line, this number is going to be how far spaced they should be. So starting from where the lines connect, this will always be 0. I'm going to count over 2 and put a line, 2 more and put a line, 2 more. So every 2 lines, I'm going to have a number. And I'm going to have some space at the end, which is absolutely okay. So now I'm just going to put the numbers from the table where I put those dash marks. So the first one will be 2, 4, 6, 8, 10, 12, 14, and one more 16. And then we have some extra space. Again, that's perfectly fine. We're going to do the same thing going up the y-axis. We have to count how many lines there are. And again, there's 8 pieces of information that we want to put on there. So we'll divide by 8 to see how far apart they'll go. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25 on this one. So 25 divided by 8 will be 3 with some leftover space. So we want them 3 apart on this one. So every 3 lines, 1, 2, 3, I'll put a line. 1, 2, 3. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Then I'll just plug in the numbers as they are on here, counting by hundreds. So we've got 100, 200, 300, I'm going to squeeze, 400, 500, 600, 700, and finally my 800. Now, to put the numbers on the graph, what you're going to do is 2, 100, my ordered pair, means I go over to 2, so the line where the 2 is, up to where it meets up with the 100, and put a dot. Over to 4, up to 200, put a dot. Over to 6, up to 300, put a dot. Over to 8, up to 400, put a dot. Over to 10, up to 500, put a dot. Over to 12, up to 600, put a dot. Over to 14, up to 700, put a dot. And finally, over to 16, up to 800, put a dot. Now, something that's important here is that we are going to connect these. And when we connect them, starting at 0, we want to connect. Put a line all the way through all of those dots, they should form a nice straight line. Because remember, anything in a ratio table is equivalent to each other. On a graph, what that means is it will be one consistent diagonal line. So that's how you go from a ratio table to a graph. So the next piece of this is for us to write two equations based on the information above, and be sure to use the variables x and y. So we're using hours as x and miles as y. So this is basically what we did in lesson 13, where we're seeing what we're doing to the hours to get to the miles, what we're doing to the miles to get to the hours. So what I'm doing is I'm taking my hours, which I'm going to be calling x. I'm multiplying it, and another way, by the way, you can write a multiplication symbol is a dot like this. So I'm just going to do that for today to show you. So I'm taking the hours, I'm multiplying it by 50, and that's giving me my miles, which I'm going to be writing as y. So again, when I write an equation, algebraically, I want my number first, so 50 first. Directly next to the variable, which in this case would be x, because I'm doing 50 times the number of hours, is equal to the number of miles, y. So that's one equation, going from hours to miles. To go from miles to hours, I take my miles, I'm dividing it by 50 to get back to the hours. So now remember to show that algebraically our miles were x, our hours were y. I'm doing x divided by 50, which remember we write in fraction form, equals the y or the hours. So those are the two equations. Hopefully that's review from lesson 13. So now there are some extra questions here. One is how many miles would they travel in 3 hours? So we can use our equations. Here, we would use the first equation. We have the number of hours, and we're trying to get the number of miles. So we would take the number of hours and multiply them by 50 to get the number of miles. So I would do 3 times 50, and that would give me 150 miles. Simple, easy as that. Whoops. Just taking the number of hours, multiplying it by 50. Now the next question is something that you'll see on your homework and you'll see on quizzes coming up. It's asking if a specific point would be on the graph. Now here's how you figure out if ordered pairs are going to be on the same graph. If you look, with each of our ordered pairs, if we took the first number, which is just the number from the first column, and multiplied it by 50, we would get the number in the second column. Or vice versa. If we took the second number and divided by 50, we would get the number in the first column. So to be able to tell if a point is on a graph, what we can do is we can see if the first number, or the 5, times 50 would give us the second number. If I do 5 times 50, 5 times 5 is 25. Attach that extra 0. So I get 250. So since 5 times 50 does not equal the 350 here, this point would not be considered on the graph. The first number has to be multiplied by the same number that all of the other ordered pairs are being multiplied by in order to be on the graph. So we would say no, it would not be on the graph. Had we done this, to find the point that would actually be there for 5, it would just be the 5, 250. That would be a point on the graph. Another way you can do it too is just take that second number, that 350, and divide it by 5 to see if you get that 50. Or 350 divided by 50 to see if it gives you 5. So a couple of different things we saw here today. Again, we revisited a ratio table and how to find the ratio and the value for that table. We found how to make a graph out of that information by creating ordered pairs. Again, ordered pairs just have to be the first column number in parentheses, comma, second number, and then put those onto the graph. We learned to count the lines and divide by the number of pieces of data we want on there to see how far spaced out they should be. Put a dot where they all connect and then draw a line to connect them. We've also reviewed how to write two equations based on a table, a multiplication equation and a division equation. We've learned how to extend that to find other pieces of information from that table. And we've also learned an important piece, which will be in your practice and it will be on homework and quizzes, is finding if a point should be on the graph or not. So hopefully you were able to follow all of this and take notes while watching. There is a play posit that you can do for practice to go along with this, so I'd ask that you start that now.